Good afternoon. Today we are going to see the problems related with indeterminacy. Already we have gone through determinate and indeterminate structures. Now I will just write the two formulas over here. That is formula for pin jointed structure. So we have for pin jointed structure, that is equal to m plus r minus 2j. So actually what is ds? ds is number of unknowns minus number of equilibrium equations. So in case of pin jointed structure, we have axial force in the member. So member have only one force. R will be the number of reactions. So these are number of unknowns. And as each joint will act as force system, where we have all forces are acting at a joint, and this is known as concurrent force system. And for concurrent force system, we have two equations at each joint, which is Fx equal to 0 and Fy equal to 0. So at each joint, we have two equilibrium equations, and therefore we have subtracted it minus 2j. If we will go to rigid jointed structures, then in rigid jointed structures, we have three forces in each member, that is shear force, axial force and bending moment. So every member have three forces. So three forces unknown for each member plus number of reaction. This becomes your unknowns. And now each joint have three equilibrium equations. So minus 3j. So that is number of equilibrium equations. If we have, if internal hinges are there, then equation becomes ds equal to, for rigid jointed structures, we do not have hinges in pin jointed structures. So ds equal to 3m plus r minus 3j minus number of members connected to it minus 1. Connected to hinge minus 1. Why? Because already one equation we are going to consider in moment equal to 0, and one extra we will get, and then we will get, therefore we are subtracting 1 from it. So if we have two members, so already we are considering one equation, moment about this joint equal to 0. But if we will consider internal hinge, then we will have two equations. So moment from left equal to 0, moment from right equal to 0. So out of two, one already considered, and therefore number of members connected to hinge minus 1. If we have three members connected, then we are going to get this as 2. So we will say this will be as C. This will be as C, or we can have this equal to, or number of equation to release, R we will say. So C already we will have in cuts. So we will consider R. Now we will solve some problems over here. So we have first this, determine the degree of static indeterminacy for pin jointed. So we know for pin jointed we have m plus r minus 2j. Now we will just calculate joints 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have j equal to 10. M we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, then 15, 16, 17, 18, 19, 20. So we have total M equal to 20. J we have 10. R we have simple support, so 2 over here, 2 over here. So we have R equal to 4. And then we will get ds, that is equal to M we have 20, R we have 4 minus 2 into 10, and we will get it as 24 minus 20, which is equal to 4. So ds for this pin jointed structure is 4. Then we have degree of static indeterminacy for this rigid jointed. So for rigid jointed we have formula, that is 3m plus r minus 3j. Now as we do not have any hinge, so we will not consider RR over here. Now you can have M, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So M we have 10, J we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So J we have 9. And R, number of reactions. So we have 3 over here, 2 over here, and 1 over here. So R we have 6. So 3 into 10 plus 6 minus 3 into 9. So we will get it as 10 into 3, 30 minus 27, 3 plus 6. So we have 9. So ds for this structure, we have 9. Then we will go to the next problem, which is again for rigid jointed, but we have internal hinge. So this is one internal hinge, this is second internal hinge. So formula we know. So now first we will have M, that is equal to, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So M we have 9. Because we have this is one member, then we have this also another member. So if I will write here, then we have 1, 2, 3, 4, 5, 6, 7, 8, and then 9. Joints we have 1, 2, 3, 4. This is hinge also joint 5. This is 6, 7, and then 8. So we have joint equal to 8. And R we have 2 over here, 1 over here, and 1 over here. So R we have 4. And number of release we have 2. Because here we have two members connected, so 2 minus 1, 1. Here also we have two members connected, so 2 minus 1. So 1 plus 1 we have 2. And then we will write equation ds equal to 3m plus r minus 3j minus rr. And then we will get 3 into 9 plus 4 minus 3 into 8 minus 2. So we have 27 plus 4, 31 minus 24 plus 2, 26. So answer we have 5. So ds equal to 5. Then we will go next problem. This was from MPSC. Now I will go fast. So we have M equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have M11. J we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have total J10 and R we have 3 at each, so 9. And then we will get DS equal to 3M plus R minus 3J. And then we have 3 into 11 plus 9 minus 3 into 10. So it comes 12. So we have DS that is equal to 12. Then we will switch over to the next problem. So this was asked in MPSC 2016. This is pin jointed. Now if we will calculate M, so we have 1, 2 horizontal, we have 4 vertical, 4 or 3, 7, and then inclined 4. So total M we have 11, J we have 6, and R we have 4. So we have ds equal to m plus r minus 2j. And then m we have 11, r we have 6 minus, sorry, r we have 4 minus j we have 6. So 15 minus 12, so we have 3. So for this ds is 3. Now we will go determine the degree of static intensity pin jointed again. Now we have joint over here. Internal hinge is not in these structures. So now two reaction over here, two over here. So now members we have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have m is equal to 15. Then number of joints we have 1, 2, 3, 4, 5, 6, 7, and 8. So J we have 8 and R we have 4. And therefore we have ds equal to m plus r minus 2j. Now m we have 15, r we have 4 minus 2 into joints we have 8. So we have 15 plus 4, 19, minus 8 2s are 16. So we will have this as 3. So ds we will have in this that is equal to 3. So this is problem number 6. Now we have problem number 7, pin jointed. So here we have one reaction, one reactions, two reactions. Then members we have in this one. So this is directly we can go over here. So this is internally determinate because open loop, internally determinate. Therefore, open loop. And therefore, we have to find only DSE, which is R minus equilibrium equations. Number of reactions we have 4. Number of equilibrium equations we have 3 plus 1 due to internal hinge. We know it. So 3 plus 1. So this will be, you can write it as 4, and then we will have this is 0. So this is ds total we have 0. Then we will have this as one problem, pin rigid jointed. So we have 3, 2, 1. So we have R6. Then we will go for M. So we have M is equal to 1, 2, Then we have joint over here. So this is third member. Then we have this as fourth, fifth, sixth, seven, 8, 9, 10, 11. So we have m is equal to 11. Now j, so we have this as 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So j we have 10. And then we can have ds equal to m 3m plus r minus 3j. So 3 into 11 plus 6 minus 3 into 10. So we will have 9 here. So ds value we have 9. And then we have last problem. So in this we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have m is equal to 12. J we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have J11 and then R we will have as all four are fixed upwards. So we have 12 and then DS we will get it as 3m plus r minus 3j minus rr. Now how much rr we will get here? So you can see number of members connected are 1, 2, 3, 4. So rr is equal to 4 minus 1 equal to 3. So we will have now 3 into 12 plus 12 minus 3 into 11 minus 3. So this is 3 into 12, 3 into 12, and then we will have only 12. So ds equal to 12. So likewise, we have to solve the problems which are from indeterminacy. So we will stop here only. So thank you.